A thin film of oil, N equals 1.4, is floating on water, N equals 1.33. When illuminated with white light, constructive interference is observed for green light. Calculate the minimum non-zero thickness of the oil film that produces this interference. So the first thing you want to do whenever you get a problem, which is thin film interference, is to draw a picture. So we're going to separate this into 3 areas. So the first one is on top of this top line, and that's usually air. And the second part is this place, which is the thin film. So pretend that that's extremely thin. And then the third part is, of course, below the line, which is going to be, in this case, water. So if we read the question, a thin film of oil, N equals 1.4. N equals 1.4 is the index of refraction. So we know that that's the index of refraction for oil. So we can write it over here. And it's floating on water. So the water is beneath the oil, and it's giving you the index of refraction of water. So we can write it over here, since this section is representing water. When illuminated with white light, constructive interference is observed for green light. So first, let's just write N equals 1 over here. And this is the index of refraction of air. So usually, not always, but usually, this is a place that you are observing the reflected light, and it's usually the air. So the index of refraction of air is 1.00. And now it says to calculate the minimum non-zero thickness of the oil film that produces this interference. So you need to know some formulas. So the important formula you want to know is 2T equals m wavelength. And this is for constructive interference. And then for destructive interference, it's 2T equals m minus 1 over 2 wavelength. But the weird thing is that it only works if m is greater than 0, this formula. So we want to figure out which of these formulas to use. By the way, T represents the thickness, so that's what we're looking for, because it's asking for the thickness. T represents the thickness of the oil film. And the wavelength in this equation, let's call it wavelength 2, that's the wavelength that is in the oil. So we can label this as N1, N2, and N3. So in these two equations, the wavelength that it's talking about is the wavelength in the oil, which is wavelength 2. And usually the question will not give you this wavelength, so you'll have to calculate it using Snell's law. Usually the question will give you wavelength 1 though. And the first step to solving this question, where it's asking for the thickness, is to find wavelength 2. So to find wavelength 2, you can use the equation, which is part of Snell's law. Wavelength 1 over wavelength 2 equals N1 over N2. So right now, we don't know what wavelength 1 is. So usually the question gives it to you, and right now the question is giving it to you in a kind of weird way, because it's telling you that the light that you're observing is green light, and that has a specific range of wavelengths, so you can just pick any wavelength you want. So if I'm looking at my chart, green is from 520 to 565 nanometers, so you can choose any wavelength in between those ranges. So let's just go with 530. And it's nanometers, so it's going to be times 10 to the 9 meters. There, now we have all we need to find wavelength 2. So it's going to be plugging it in, 530 times 10 to the power of 9 over wavelength 2, what we're looking for, equals N1 is 1, and N2 is 1.4. And we can cross multiply, so 530 times 10 to the power of 9 times 1.4 and divided by 1. And the answer I got is 7.42 times 10 to the 11. Oh, I made a mistake. So if it's nanometers, it's going to be 10 to the negative 9, not 10 to the 9. So let's try this again. 530 times 10 to the negative 9 times 1.4. Okay. So it's going to be 7.42 times 10 to the negative 7 meters. There. Now, the next thing you want to do after finding this value is to figure out if there's a phase shift or not. So to figure out if there's a phase shift, it has to be going from a fast on top to slow on bottom. And this is the medium. So the medium has to be going from a fast medium to a slow medium. But the confusing part is that we don't really know if, like, for example, if you don't know which one's faster or slower, you can look at the index of refraction. If the index of refraction is bigger, that means it's slower. Okay, so we have to do this twice, once for this, and then once for this. So from air to oil, if we take a look at the index of refraction, the index of refraction for air is 1, and the index of refraction for oil is 1.4. So if we take a look at which one's bigger, 1.4 is bigger than 1, which means that oil is slower than air. That means there's going to be a phase shift. So I'm going to mark this as a check mark. And then the next thing you want to do is look at this barrier. So it's going from 1.4 to 1.33. That means it's going from a slower medium to a faster medium, because the bigger the index of refraction, the slower it is. That means there is no phase shift. So remember how I said this formula is for constructive, and then this one is for destructive. If there's only one phase shift, the formulas get switched, which means this formula now becomes destructive and this formula now becomes constructive. So as you can see in this problem, there is one phase shift, which means these formulas are going to be switched. So which one do we want, constructive or destructive? Well, in the question, it clearly says constructive interference. So we're going to have to use this equation because the formulas are switched. Because of the phase shift, we're using this formula and not the one above. So let's clear some things up. So the weird part is that m cannot equal to 0 because then it's going to be negative 1 over 2, which is not what you want. But technically m can be 0, 1. M can be 0, 1, 2, 3. Okay, let me explain what m actually is. So if there's a double slit interference, okay, it's like this. Light is coming through here and is passing through both of these areas. The pattern that's going to appear on this wall thing is like this. So notice that this thing is the largest wave. So this point is referred as m equals 0. This bright spot, whenever it's like curvy, it's a bright spot. So this is m equals 1. And this is m equals 2. This is also m equals 1. And this is m equals 2. Now, this is m equals 0. Now, I'm just going to talk quickly about dark spots, because I think it is relevant, but yeah. So dark spots is represented with the formula n. However, a dark spot cannot have n equals 0 because the first dark spot is over here and as well as this. So these are both n equals 1. So as you can see, there is no such thing as n equals 0 because in the middle it's a bright spot. So this is n equals 2. And this is also n equals 2. Okay, so let's use this formula. 2t equals, remember that m cannot equal to 0 because for some reason it's going to be negative. So yeah, and since it's asking it's asking for the minimum, because m can be 1, 2, 3, or 4, or 5, or basically any number. It's asking for the minimum, and the m that's going to give you the minimum is the smallest m that you can have, and it's not 0, it's 1. So we're going to have 1 minus 1 over 2 times wavelength 2, which we calculated down here. It's 7.42 times 10 to the negative 7. One minus 1 over 2 is 1 over 2. And this is all multiplied by 7.42 times 10 to the negative 7. And then if you divide t by 2, you divide the other side by 2. So you're going to get divided by 4. Okay, so let's plug this in. So the answer that I got is 1.855 times 10 to the negative 7. And looking at sig digs, the smallest number of sig digs that the question is giving you is n equals 1.4, which is 2 sig digs. So instead of 1.855, we're going to round it to 2 sig figs, which is 1.9 times 10 to the negative 7 meters. And if you want to change this to nanometers, all you gotta do is multiply it by 10 to the power of 9. Which is 190 nanometers. And that is the answer for this question. Walking in a parking lot, you see a puddle of water, n equals 1.33, that looks green, wavelength equals 556 nanometers. You therefore assume there must be some gasoline, n equals 1.25, floating on the puddle. What are two possible thicknesses that the gasoline layer could be? So again, we're going to start off with the picture. And the thingy in the middle is usually the thin film. So in this case, it's going to be gasoline, and we can call this N2 in the question, which says it's 1.25. And it's floating on the puddle, so beneath it is going to be water, which is telling you it's 1.33. And we can just assume that we're looking at this from air. Okay, now it's also giving you the wavelength. So is this wavelength the air or the oil? So I thought it was the oil because it says it looks green, but you can't actually observe the oil if you're in the oil. So it's talking about the wavelength that you're observing that is looking green. So it's going to be this wavelength. Because when you're looking at something, you're looking at it from the air. So it's going to be 556 times 10 to the negative 9 meters, since it's nano. And also, just in general, these questions, they give you the wavelength of the air and not really the wavelength in the film, just because they want you to calculate it. So let's go ahead and do that. The formula is wavelength 1 over wavelength 2 equals N2 over N1. So we're just gonna 556 times 10 to the negative 9 over wavelength 2 equals 1.25 over 1.00. Cross multiplication to get wavelength 2 is 556 times 10 to the negative 9 times 1 divided by 1.25, which is 4.448 times 10 to the negative 7 meters. Now what we want to do is look for the phase shift. So remember, a phase shift only occurs when it's going from a fast medium to a slow medium. So let's look at N1 and N2. N2 is 1.25, which is bigger than N1. So this means it's going from a fast to a slow medium, because slow mediums have a higher index of refraction. So that means there is going to be a phase shift here. Now let's look at N2 and N3. So N3 is 1.33, which is bigger than 1.25. So this means there's also a phase shift here. So if there's, remember the formulas 2t equals oh yeah, also I forgot to mention that this formula, these two formulas are used when you want when you see the light. So when it's a bright spot, because it has M in it, which is referring to a bright spot. Some questions will just say that you can't see the light or something like that, like the light's getting blocked. And in that case, you're going to use the exact same formula, except replace M with N. Okay, so this is constructive and this is destructive. But if there's one phase shift, they get switched. However, as you can see, there's two phase shifts. So that means it cancels out. So if there's 0 phase shifts or 2 phase shifts, nothing happens. This remains constructive and this remains destructive. So in this case, it says that it looks green, which means it's going to be constructive because you can see it. So that means we're going to use the formula 2t equals m lambda, since it's asking for the 2 possible thicknesses. What are 2 possible thicknesses? So m can be 0, but it's kind of confusing because if m is 0, t is also going to be 0. And it's asking for the 2 possible thicknesses, and I just think that having 0 as your thickness is kind of weird. So to be safe, let's just say m equals 1 and then m equals 2 for the 2 possible thicknesses. So 2t equals 1 times 4.448 times 10 to the negative 7. And solving for t is going to give you this divided by 2. Which is 2.22. Okay, so let's look at the number of sig digs. In this question, every number has 3 sig digs, so we're going to keep it at 3 sig digs. So this is one possible thickness. Make some space, because it's asking for 2 possible thicknesses, which just means you're going to change the m, because m can be any number, just not really 0, because then it gets kind of weird. So imagine m is now going to be 2, so then that's going to give us our second thickness. I'm just going to do this in my calculator. So we're going to have 2 times the wavelength, which is 4.448 times 10 to the negative 7. And solving for the thickness, dividing by 2, is going to give us, again, 3 sig digs. So 1, 2, 3. So the answer to this question is this and this. Two glass plates are squeezed together, leaving a thin film of air with a thickness of 130 nanometers. What wavelength of light will reflect most strongly from this film? So the first thing we want to do is draw a picture. In this question, it's saying that the thin film is air, and there's 2 glass plates that are surrounding it, which means here it's going to be 1.52, which is the index of refraction of the glass plate. And this is also going to be the index of refraction of the glass plate. And this is going to be the index of refraction of the air. since this is a thin film. So it's also telling you the thickness, and let's convert that to meters. So it's going to be times 10 to the negative 9. Now the two formulas that we use is 2t equals m lambda for constructive, and then 2t equals m minus 1 over 2 lambda for destructive. Now let's see if there's any phase shifts. 1.52 to 1 is going to be, well, 1.52 is larger, so there's going to be no phase shift. And from 1 to 1.52, 1.52 is larger, meaning that it's slower, so there is going to be a phase shift here. So in that case, we're not going to use this formula because it is constructive, since it's saying which one will reflect most strongly, implying that you can see the light. But we're not going to use this formula because there is one phase shift, which means we're going to have to use this since it's reversed. This is going to be the equation for constructive. Now it's saying what wavelength of light will reflect most strongly from this film. And if we go back to our double slit experiment, what value of m will give us the largest wavelength? The largest, basically what value of m will give you the strongest reflection. So the stronger it is, the closer it is to the slits. So it's going to be this. But for some reason, using m as 0 gives us a negative number. So the second best option is going to be these two, which is m equals 1. So in this question, we're going to use m equals 1. So 2 times t equals 1 minus 1 over 2 is 1 over 2. So 1 over 2 times lambda. So actually we can just replace the 1 with lambda. And then to get lambda, you multiply both sides by 2. So just doing this quickly, it's going to be 4 times 130 times 10 to the negative 9. And you get 5.2. So looking at the sig digs, 130 nanometers has 2 sig digs. So we're going to keep this at 2 sig digs. And this is actually the final answer, because it's asking what wavelength of light will reflect most strongly from this film, and that's going to be the wavelength of light that you can see. So it's going to be this, because you can see it in the air and you can't see it if you're in glass. So this wavelength in this equation is actually wavelength 2. So that's why this is the answer to this question.